Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now if you find my videos interesting and important to your studies, also please don't forget to subscribe. So this video discusses distributed forces in preparation to the internal force systems and the construction of the shear and moment diagrams in beams. Level 11, calculate the supporting force Ra and moment Ma acting on the loaded cantilever beam at A. So here's the given figure. For the solution, let's call the area of this loading diagram as F. So reactions AY, by the way, this is 1/3 of 6 feet, so 2 feet. So the distance of the line of action of F from point A is 8 feet. So call that AY, and AX is 0, so AY is equal to RA, and it is expected to be upward. Then moment at A is expected to be counterclockwise. So for the solution, AY equals F, then F is the area of this loading diagram, 1/2 of 6 times 120. So therefore, AY equals RA equals 360 pounds upward. Then for MA, we sum up moment about A, so MA equals F times 8. MA equals 360 times 8. So MA equals 2880 pound-feet counterclockwise. Level 12. Determine the reactions at the beam supports for the given loading. So here is the figure, and let's call the equivalent area or force in this triangular loading as F1, and its distance from A is 2/3 of 12, so that's 8 inches. Then F2 on this uniform loading, rectangular loading, its distance from this left end of the loading is 1/2 of 20, so 10 inches. So reactions, we have AY and AX is 0. So AY is also RA, and moment at A is, let's assume, counterclockwise. So for AY, we compute first F1 and F2. So F1 is 1/2 of 12 times 50 pounds per inch, so it is 300 pounds. F2 is 20 times 50, 20 inches times 50 pounds per inch, so that's 1,000 pounds. Therefore, if we sum up forces Y, AY plus 400 then equals F1 plus F2, 300 plus 1,000. So AY equals 900 pounds. Therefore, RA is 900 pounds upward. For MA, summation moment A is 0, assuming counterclockwise positive, so MA plus 400 times 38 inches, so that's 6 plus 20, 26 plus 12, 38. Then minus F1, 300 times 8, minus F2, 1000 times 10 plus 12 is 22. So 1000 times 22 equals 0. So from there we can solve MA. MA is equal to 9,200 pound-inch counterclockwise. So that's it. Level 13. Determine the reactions at A and B for the beam subjected to a combination of distributed and point loads. So here's the beam. We will call the equivalent load in this left triangular loading distribution as F1. And because the horizontal component of distance is 1.8, so 2/3 of 1.8 is 1.2, therefore F1 exactly passes through this pin. Then F, so this is F2. So 1/3 of 1.2 is 0.4. So this is 0.4 meter. Then let's resolve the inclined load, point load 1.5 into two components, vertical and horizontal. So for the vertical component, it is 1.5 cosine 30 downward, and the horizontal component is leftward 1.5 sine 30, so 0.75 kilonewton as shown. Then for the reactions, we have AY and AX and R sub B. So summation forces X, AX is obviously 0.75 kilonewtons rightward. So F1 is 1/2 of 1.8 times 2, so it is 1.8 kilonewtons. F2 is 1/2 of 1.2 times 2, so it is 1.2 kilonewtons. So AX is 0.75 kilonewtons rightward. Summation moment about B equals 0 to solve for AY. So AY times 4.8 meters, so 1.8 plus 1.8, 3.6 plus 1.2, so 4.8 meters. Then minus 1.5 cosine 30 times 1.2. Then minus F2, which is 1.2 times the moment arm is 3 plus 0.8. This is 0.8, 2/3 of 1.2. So 3.8 minus 1.2 times 3.8. Then minus F1 times 4.8 minus 1.8 times 4.8 equals 0. So from there, we can solve AY. AY is equal to 3.075 kilonewtons upward. So the magnitude of reaction at A, square root of 0.75 square plus 3.075 square. So R sub A is 3.165 kilonewtons up to the right. For the inclination, tangent theta AX is 3.075 over 0.75. So theta AX is equal to 76.29 degrees. Therefore, RA is 3.165 kilonewtons directed up to the right through at an angle of theta AX 76.29 degrees. So it is understood counterclockwise from the positive x-axis. Likewise, summation moment about A equals 0. So we have R sub B times 4.8 counterclockwise positive minus 1.8 F1 times 0. Then minus 1.2 times 1. 0.4 plus 0.6 is 1. Minus 1.5 cosine 30 degrees times 3.6. So 1.8, 1.23 plus 0.6, so 3.6 equals 0. So R sub B is equal to 1.224 kilonewtons upward. Level 14, determine the reactions at the supports of the beam, which is loaded as shown. So here's the given figure. Then let's divide the loading into rectangular loading and triangular loading as shown in the figure. We will call this rectangular loading as F1, and its line of action is half of 8 meters from left, so 4 meters from left, so 3 meters from the right, or this is 2 meters. So 3 meters from B. Then F2 for this triangular loading, it is 1/3 of 6, so this is 2 meters. And its distance from the right support B would be 7 meters minus 2. But anyway, I will not level it. Then for the reactions, we have AY, AX is 0. So RA is equal to AY, automatic. Then this is R sub B. So summation of moments about B equals 0, clockwise positive. So F1 is 8 times 400, 3,200 newtons. F2 is 1/2 of 6 times, this is 400, 800 Newton per meter minus 400. So 1/2 of 6 times 400, F2. And that is equal to 1,200 newtons. So summation moments about B equals 0, AY times 7 minus F1 3,200 times 3 minus F2 1,200 times 5 equals 0. So solving for AY is 2229 newtons. Then AY, then RB, summation of moments about A equals 0. So RA is 2229 newtons upward. Summation of moments about A equals 0, counterclockwise positive, RB times 7 minus F1 3,200 times 4 minus F2 1,200 times 2 equals 0. So R sub B is equal to 2171 newtons upward. So that's it for this level 14 problem. Then for this level 15 problem, determine the reactions at the supports of the beam which is loaded as shown. So here is the given figure. Let's call this F1, and its line of action is 2/3 of 3 from B, so 2 feet, 1 foot from A. So let's have 2 feet from B. Then F2 for this triangular loading, its distance from C is 1/3 of 6, so 2 feet, 4 feet from B, 2 feet from C. Then F3, 1 foot from C and 1 foot from D. So F1 is 1/2 of 3 times 480, the area of the loading diagram, so 720 pounds. F2 is 1/2 of 6 times 600, and it is 1,800 pounds. Then F3 is 2 times 600, 2 feet times 600 pound per foot, so it is 1,200 pounds. So we have AY, BY, BX is 0, and R sub C. Summation of moment about C equals 0, so clockwise positive, we have BY times 6, then minus F1 720 times 2 plus 6, so 8 feet, minus F2 times 2, so minus 1,800 times 2, then plus F3 1,200 times 1 equals 0. So from there, BY can be solved. It is equal to 1,360 pounds upward. So R sub B is 1,360 pounds upward because BX is 0. Then summation moment about B equals 0. So R sub C times 6, counterclockwise positive, plus F1 720 times 2, minus F2 1,800 times 4, then minus F3 1,200 times 7 equals 0. So R sub C is equal to 2,360 pounds upward. So that's it.